Okay? So this is the next thing. It says the derivative of an integral. Derivative. So these two guys who developed calculus, they didn't have graphing calculators or anything like that. So they had to figure out another way to find the definite integral. Okay? And first of all, what they said, this is called the derivative of an integral. A sub x of f of t dt equals f of x. So if you have some function, okay, f, okay, and you go from a to x, these two guys, Leibniz and Newton, were the developers of calculus, okay, weren't they? Okay, knows all about the history of those German guys, right? So if I move this x, okay, I'm going to get a different value for the integral, right? And so what these two guys discovered is that if I take the derivative of the area under the curve, I'm going to get back the function, okay? Which means that the antiderivative of the function must be the integral, okay? And so just kind of take this, just shake your head and go, yes, that. And the reason they have f of t dt right here is because you're plugging in this x as a variable in for x. So the value of the integral changes depending on where this x moves, right? Where that x moves. But what they discovered is, aha, the area under this curve is the area under this curve, the derivative of the area under this curve is equal to the function itself, okay? And the way you find that function is by taking the antiderivative of it. Does that kind of make sense? And so if I have the function, let's see if I can do this without messing up. So if I want to take the integral of the function from a to x of f of t dt, that's equal to some antiderivative. So this is an antiderivative of f. Okay? Antiderivative of f plus a constant. Yes? Okay? Because you have to have a constant whenever you take the antiderivative. Okay? Furthermore, if I substitute a in for x, I get the integral of f of t dt is equal to also the antiderivative of a plus c, because I'm finding the antiderivative when x is over here, but here I'm finding the antiderivative when x is over here. So what is the value of an integral from a to a? 0. Okay? So if I want to find the conclusion to that is that the integral from a to x of f of t dt is equal to this minus this, which is equal to f of big X plus c, or big F of x, which is the antiderivative, minus f of a, also plus c. What happens to these c's? You don't really have to worry about the derivation and where it comes from and all that kind of stuff. But this idea leads to the fundamental theorem of calculus, which is this. The integral from a to b of f of x dx, right, is equal to f of b minus f of a. where big F represents the antiderivative of little f. Okay, because the c's cancel out. You understand that? Okay, c's cancel out. And this formula is like super, super duper important. Okay, and they don't call it that in this chapter, but this is called the fundamental theorem. Fundamental theorem of calculus. And they found that by kind of going backward, looking at the integral, taking the derivative of the integral, and realizing that the derivative is the function, and so if I take it anyway. So this is the biggie, all right? So say going back to that example problem that I had, that we did with the graphing calculator. Now I want to find the integral, what was it? The integral from 0 to 3 of 4 minus x squared dx. Yes?
Yes.
Let's find this without a graphing calculator. What's the antiderivative of 4 minus x squared? 4x minus x cubed divided by 3. There is a constant there, but it turns out we're not going to have to worry about that constant, right? Because all I have to do is go f of a, big F of a minus big F of b. So you don't really have to worry about the c when you're doing the fundamental theorem. So we're just going to get rid of that there, okay? And so what I'm going to do is I'm going to go big F of 3 minus big F of 0. And if I do that, I get out 4 times 3 minus 3 cubed over 3 minus, and this number, just because in this case it comes out to be 0, it's not always 0, okay? Because if I plug in -1, it would definitely not be 0, right? So if I want, I'm just trying to show you that you'll get the same answer as we did using our calculator. So 0 cubed over 3, well, this quantity is what? 0. And so I get 4 times 3, which is 12, minus 27 over 3, which is 9, right? Minus 0. So what do I get out? What's 12 minus 9? 3. Was that the value of the integral when I did it on my calculator? Yes. Okay. So that's really cool stuff. Now one more example problem, then I promise I'll be done. Okay. So one more example. Okay. Example. Remember we did this one with that little exploration? The integral. Let's do this. The integral from 0 to pi of sine of x dx. Remember we did this? And we found out that this integral was, does anyone remember from when we did that investigation? What did they tell you that was equal to? 2? Okay?
Yeah.
Let's show that this is equal to 2. So what's f of x in this case? What's the antiderivative of sine of x?
Negative cosine.
Negative cosine. It's not cosine, it's negative cosine. Remember, because the derivative of cosine is negative sine. And so we have to put a negative in front of it. So f of x plus negative cosine of x plus c. Again, we're not going to have to worry about the constant. So I'm going to go f of, so I'm on f of pi minus f of 0. So I'm going to get negative cosine of pi minus negative cosine of 0. You guys remember what the cosine of pi is? Negative 1, right? So I'm going to get negative 1 minus, what's the cosine of 0? 1. And so that gives me plus 1, which is equal to 2. Whoa. Isn't that cool? So what that gives you,
I can't believe it.
I can't believe it. So that's why this was so dramatic, because these guys figured out how to, without using a graphing calculator, they could actually figure out the exact value of tons and tons of functions. And then there's the whole second part of the semester, the whole second part of your year is figuring out algebraically how to integrate more complicated functions, because it's easy to integrate something like this, but it's harder to integrate something like 1 over x squared plus 1 or something like that. What would that be? Oh! You're too smart, okay? Because you do have 1 in your, so the integral of this dx, don't forget dx. Do you remember that this is the inverse tangent of x? So in your homework, you have one like this where you're trying to find the integral of something that looks like that. And that's the definition of the inverse tangent of 1, right? Inverse tangent of x. Okay, what if they said, so, what if they said find the, what if they said find the average value? Find the average value for the same integral, or for the same function from 0 to pi. What if they said that? How would I do that? I just divide it by pi. So the average value would be 1 over pi minus 0, pi times 2, or just 2 over pi. Okay? And that's the height of a rectangle that would give you the exact area underneath that curve. All right? So that's it. Your homework, boys and girls, is page 295, 15, 17, 19, 22, 25, 27, 29, 31, 35, 36, 50, and 51. Okay? And that's the end.